Hello, my little mathematicians. Today we're going to introduce least common multiple. Okay, the least common multiple is different than the greatest common factor. This time it's the smallest number that two or more numbers can multiply to become. Okay, so first off, let's start with the warm up. Okay, as always, try to pause the video, try them yourself, then unpause it and come back. Okay, so you paused it and now you're unpaused it and you came back with us. Let's see how you did for the warm-up part up here. It says list all the factors of 15 in order. So what I like to do is I write the number 15 and I start with 1. Okay, 1 times 15 is 15. 2 can't go in. 3 can go in because 3 times 5 is 15. 4 can't. 5 is already used, so there you go. That's all of the factors that can go into 15. So now I write them in order and you just follow this little U. 1, 3, 5, 15. And now you have all of the factors in order of 15. Let's try of 24. Okay, well, 1 times 24, 2 can go in 12 times, 3 can go in 8 times, 4 can go in 6, 5 can't go in, 6 is already used, so that's all of them. So you just go down the U, 1, 2, 3, 4, and back up, 6, 8, 12, 24. 1, 2, 3, 4, 6, 8, 12, 24. And that is all the factors of 24. The next one says list the factors of 48. Well, 1 can go in, 2 can go in, half of 4 is 2, half of 8 is 4, 3. Okay, 3 is a little bit tough. So remember the divisibility rule for 3 is that if you can add these digits together and 3 can go into that sum, then 3 can go into the number. Well, 4 plus 8 is 12. 3 can go into 12, so 3 can go into 48. So now at least when I do the long division, I know I'm not wasting my time. So it's going to be able to go in. And 3 goes into 18 6 times. So there we go. 3 times 16 is 48. 4 we know can go in 12 times. 5 can't go in because it doesn't end in 5 or 0. 6 times 8 is 48. 7 can't go in. 8 is already used. So there we go. That's all of them. It's 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Okay, last one. This one says find the greatest common factor of 84 and 108. So this is a review of the other day. We're going to do our little ladder method. Think to yourself, what can go into both of these? Well, 2 can go in. That's 42. And half of 10 is 5 and half of 8 is 4. And I know 6 can go into both of those because 6 times 7 is 42. 6 times 9 is 54. Nothing can go into both 7 and 9. So I'm done. Those two numbers multiplied together equal my GCF. So my GCF is 2 times 6, which is 12. Now, some of you, your ladder would have looked different, but you still should have gotten a GCF of 12 as long as you kept going till you couldn't go anymore down here. Like you could have started with 3 or you could have started with 4. Lots of different options. You could have even started with 6 up there. As long as you kept going till you couldn't go anymore, we all should have gotten a GCF of 12. Okay, now let's focus on the difference between GCF and LCM. Okay, so the greatest common factor, remember, we normally refer to as GCF. And this is the biggest, that's the greatest number that can divide into the set of numbers. So a factor can divide into numbers versus a multiple is what numbers multiply to become. Okay, so for these, let's list all the factors of 12 and 24. Well, we already did 24 up here, so now let's do 12. Well, that's 1 times 12, 2 times 6, 3 times 4, 4 is already used, so that's all of them. So 12 is 1, 2, 3, 4, 6, 12. And 24, we already did, was 1, 2, 3, 4, 6, 8, 12, and 24. Now to find the greatest common factor, that's the biggest number that can multiply that can divide into both of them. So start with the biggest one right here, and look, they share it. So the biggest number that can go into both is 12, but that's irritating to write them all out like that, right? So that's when we do the shortcut like we did up here, where you have 12 and 24, and let's say we didn't know it was 12. Let's say we started with like 6. 6 times what is 12? 2. 6 times what is 24? 4. And then you're like, oh, I can keep going because something can go into both 2 and 4. 2 can. 2 times what is 2? 1. 2 times what is 4? 2. I can't keep going anymore, so those are my GCF. 6 times 2, which is 12. There you go. Okay. So for these, if you were to have listed it out, your factors of 4 and 6, you have 1 times 4 and 2 times 2. There you go. You came across a double, so you're done. For 6, it's 1 times 6, 2 times 3. 3 is already used now, so you're done. Okay, so 1, 2, and 4, and 1, 2, 3, and 6. So look here. Do they have share 4? No. But the next one down is a 2, so they share a 2. Let's see if we would have gotten the same thing with the ladder method. 2 can go into both. 2 times 2 is 4, and 2 times 3 gives you that 6. Can't keep going. Yep, there was your GCF of 2. Okay, we're going to use this same method, you'll see, when we're doing the LCM. Okay, so let's skip down. The least common multiple, we're going to stand for LCM. Okay, that's the smallest, just like the word least, number that a set of numbers can multiply to become. So first, this time we want to list the multiples of the numbers and pick the smallest that they share. So here we listed the factors and picked the biggest. This time we're listing the multiples. So for 12, you have 12 times 1 is 12. 12 times 2 is 24. Times 3 is 36. Times 4 is 48. And it would keep going. Okay, now let's try the multiples of 24. 1 times 24 is 24. 2 times 24 is 48. And you can see they already share right here, the first number. They share tons more. Like these numbers can keep going and going and going, both sets. That's why we picked the smallest multiple, okay? So this is what's happening for the LCM. Like let's do this one, 4 and 6. Okay, so list the multiples of 4. What can 4 multiply to become? Well, 1 times 4 is 4. 4 times 2 is 8. Times 3 is 12. Times 4 is 16. Let's stop, and if I need to add more, I can, but let's check the 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And it keeps going, but I noticed that they already share a 12. All right, now this is technically what you could do when they say find the LCM. I could list all the multiples and find the smallest one that they share. Just like when I found the GCF, I could have listed all the factors and found the greatest one that they share. But wasn't the ladder method so much easier? Let's see the shortcut for LCM. Want to know what's nice? It's actually the same thing. We're going to do the ladder, but then there's a twist. Okay, what can go into 12 and 24? Well, we already knew it was 6, and then a 2, or technically you could have just started with the 12, and 12 goes into 12 times 1 is 12, and 12 times 2 is 24. Okay, you just would have had a shorter ladder. Now this gives you the GCF, right? But we don't want the GCF. We actually want the LCM. So I'm going to use all the numbers along the outside, not just the side, but all the numbers along the outside that make up an L for LCM and multiply those together. And that's going to give me my LCM. 6 times 2 is 12. 12 times 1 is 12, and 12 times 2 is 24. And look at that. That's what we said it would be. Okay, let's test it with this one, 4 and 6. What can go into both 4 and 6? 2, because 2 times what is 4? 2. And 2 times what is 6? 3. I can't keep going, but instead of just circling my GCF, this time they want the LCM, so multiply all of these along the outside that make up your L. And 2 times 2 is 4. 4 times 3 is 12. Look at that. I got the right answer that I was supposed to get. So you can pick however you want to do it. You could list all the multiples out and then find the smallest one that they share. But I think doing the ladder method is a lot easier, just like it was up here. So the twist is, if you're asked to find the GCF, it's just the number along the outside. But if it's the LCM, it's all of these that make up the L. Okay. It is, I want to make a note, like later on, we're going to be asked to find the LCM of 3 numbers. It is difficult to do the shortcut method of finding the LCM if you're asked to find it 3. So we're going to show you a little trick. But before that, let's do some word problems. Like, when does this come up in real life? Well, this problem, number 5, says, today the soccer team and basketball teams will play a game. The basketball team plays a game every 3 days, and the soccer team plays a game every 5 days. How many days before they both play a game on the same day again? So whenever you see a type of problem that's, I like to call it like a scheduling problem, that's going to be an LCM problem. Because if you think about it, like let's use, for instance, a train station, okay? A train is leaving the station every 5 and 10 minutes. Okay, so the first one leaves 5 minutes, and then 10, 15, 20, 25, 30. Okay, the other one's leaving 10, 20, 30, 40. When's the first time they both leave at the same time? 10. So that was like the smallest number they both could multiply to become. Also, if it's something like a contest, they're giving away something, like every 50th customer gets a gift card, every 100th customer gets like free groceries. Basically, what you're going to do is you're trying to determine who will be the first one to get both prizes. That's another type of LCM problem. Okay, so if it's a scheduling type thing, it's LCM. So here, this happens every 5 days, and then the other one happens every 3 days. So when's the first time they're both going to happen on the same day? Okay, so let's do the ladder. Can anything go into 3 and 5? Nope, just 1. Because 1 times what is 3? 3. And 1 times what is 5? 5. So then multiply all those. 1 times 3 times 5 is 15. So the first time that they're both going to happen at the same time is in 15 days. All right, this one, not a scheduling problem, but you're trying to find the smallest amount of things that you can buy so that they have a matching amount, because this person doesn't want to have extra buns and they don't want to have extra patties. They want to have matching amounts. So what's the smallest number of packages that he has to buy in order to have the right amount? It says that the hamburger buns come in packages of 6 and that the meat comes in packages of 10. So how many packages will chef need to buy if he wants the same number? Okay, so you have 6 and 10. What can go into both? Well, 2 can, because 2 times what is 6? 3. And 2 times what is 10? 5. So then I can't keep going, so I'm going to multiply all those. You have 2 times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is 30. So that's 30 packages. It's a lot, huh? Now, that's just what they asked. They asked how many packages do you have to buy, but it's not 30 of each, because then they wouldn't match, right? This has 6 and this has 10. So the question did ask how many packages. It's 30. But if you wanted to be more specific, that means that technically you want 30 patties and 30 buns. So if the buns come in packages of 6, how many times does 6 go into 30? 5. So 5 packs of 6 buns. And these come in packages of 10. So how do you get 30? 3, right? Because 10 times 3 is 30. So 3 packs of 10 patties. And do you want to see something really nice? Look at the number down here at the bottom. 5 is going to go with the 6, and 3 is going to go with the 10. And 10 was talking about the number of patties, and 6 was talking about the number of buns. Just a nifty little trick of how that works. All right, my little mathematicians. Hopefully you feel a little bit comfortable with LCM and word problems. Now we're going to move on to a tricky thing when they ask you to find it of 3 numbers. Okay, first off, let's do it. If you're like, well, I like just listing them. Okay, list all the factors of 8 for me, of 10, and of 14. Okay, pause the video, go list them. Okay, you unpaused it, you're back with us. And if you were to list them, I got as far as 80, 100, and 140. I listed all the factors out to 10, multiples. I still hadn't found one. So I'd have to keep going, even after multiplying all the way up to 10 times each of those. That's a pain in the butt, right? So instead, we're going to do what I like to call the double ladder method. So what you do is you first pick these first 2 numbers, okay? 8 and 10. And I'm going to find the LCM of those. So 2 can go into both 8 and 10. 2 times what is 8? 4. 2 times what is 10? 5. Can I keep going? No. So now I find the LCM. That's 2 times 4 times 5. Well, 2 times 4 is 8. 8 times 5 is 40. Now I'm going to take that LCM of those first 2 numbers, which was 40, and that last one that we haven't dealt with yet, the 14, and I'm going to do a ladder with those. That's why I call it a double ladder, because you do a ladder twice for the same problem. Okay, what can go into 40 and 14? 2 can. 2 times what is 40? 20. And 2 times what is 14? 7. Can I keep going? Does 20 and 7 have anything in common? Nope. So you have 2 times 20 times 7. That's, let's do this way. Okay, 2 times 7 is, 20 times 7 is, 7 times 2 is 100, or is 14. Tack on the 0 is 140, and then times 2 is 280. Okay, or 2 times 20 is 40, 40 times 7, 4 times 7 is 28, tack on a 0. You can go from the beginning or from the end, whichever makes it easier for you to multiply out. But that is how I find the LCM of 3 numbers, is you do a double ladder. That's a lot easier than if I would have listed them all out. I would have had to list all of them out up until I got to 280. Ugh. Okay, so why don't you try it of 12, 15, and 20? Okay, you paused it to try it. Now you unpaused it. You're back with us. Let's see how you did. You had 12 and 15. What can go into both of those? 3 can. 3 times what is 12? 4. And 3 times what is 15? 5. Can you keep going? Nope. So find the LCM. That's 3 times 4 times 5. 3 times 4 is 12. 12 times 5 is 60. So now I have the LCM of those 2 numbers, and I want to also find it of that third number. So what can go in to both 60 and 20? 10 can. Well, 10 times what is 60? 6. And 10 times what is 20? 2. Can you keep going? Yep. 2 can go into both of those. 2 times what is 6? 3. And 2 times what is 2? 1. Can I keep going? Nope. So multiply all those. 10 times 2 times 3 times 1. 10 times 2 is 20. 20 times 3 is 60. And 60 times 1 is 60. So the smallest number that all 3 of those can multiply to become is 60. And congratulations, my little mathematicians. You have now mastered how to find the least common multiple. Good job.